Alrighty, fellas, continuing on, we're going to continue with looking at functional dependencies by working in a slightly more complicated example. This is the order item table. It stores the items that were ordered for each order and how much of each item was purchased and the total amount paid for those items. So we can see here that for order 1000, these two items were purchased, one of each, for this amount. So we're going to begin breaking it down by identifying functional dependencies here. And what we're looking for when we identify functional dependencies are badly designed tables. What we want to see when we do functional dependencies on a table is where the key determines everything, and that's it. We shouldn't have any more functional dependencies in a well-designed table than just the key determines everything. If we find something else, then that's a problem we need to get rid of, and I'll demonstrate in this example shortly. So let's have a look at order item. Does order number determine anything? Well, we've got multiple instances of some of these orders. Well, order 1000 always has one. Order 2000 doesn't always. And it doesn't make any business sense either. You have to consider the fact that databases store data for a business, generally speaking. So the data has to fall within the lines of business logic. Let's say, just for giggles, that the quantity here was 4. And these were the only two orders, then we could assume that order number determines quantity if we ignore these order 3000 ones. But that doesn't make any sense. You can't tell a customer, well, your order 3000, so that means you have to order 3 of everything. That doesn't make any business sense. So the functional dependencies that you find have to match the data, and they have to also make sense. So keep an eye out for that as well. So order number doesn't determine anything, really. We've got different prices, different extended prices. Okay. What about SKU? Well, SKU doesn't necessarily determine quantity. It doesn't determine the order number, because we've got 2 different orders for the same SKU. Now, the price is always the same. These are always $50. So, and that makes business sense too, because an item should cost the same no matter who bought it. So, we can say that SKU determines price, which is good. Item 101-100 costs $50. Cool. Makes sense. Alright, what else do we have? Quantity. Quantity doesn't really determine anything. That's one of those business sense kinds of issues. If I tell you that I bought 3 of something, you shouldn't know what I bought 3 of. Oh, well then you must have been shopping for cookies today. No, that doesn't make any sense. I can order 3 of whatever I please, so long as you've got the stock to match. Okay, what about price? Well, we've got several $50 items here, ordered in different orders, different extended prices, so price doesn't match anything. What about extended price? Well, extended price doesn't, let's see, we've got a couple $300 items, but they were one of something. Well, here's a couple of $100 extended price, 2 of each, different items, different orders. So no, extended price doesn't determine anything either. Well, now you have to start getting into what you know about the data, certain combinations of pieces, because this is not the only functional dependency in this table. So let's let's think about the business sense of SKU determines price. We were talking about that earlier. If I have a pencil, it should cost me, I don't know how much pencils cost, a quarter. I mean, it's just wood and graphite. But what if a pencil was purchased as a promotional or was on sale? Like at the beginning of the school year, school supplies are like ridiculously discounted. Well, in that case, a pencil might cost less for that order, depending on what time it took place. So you could argue on a business sense that the order number in the SKU determined price. So for example, if I bought a $50 dive mask in one order, it could be on sale for the next order and I bought it for $25. That makes sense. This is a great example of needing to apply business logic to what you do. You also need to consider that we already have worked with a functional dependency in this table that we haven't identified yet. And that is quantity and price determine extended price. And we've also discussed the fact that extended price really shouldn't be in this table at all, because not only does it violate design principles, but it's a formula. We should just have the computer calculate that for us. So there is also well, let's think about that order number and SKU determines price thing, because we're considering like promotions and stuff like that. Does it determine anything else? Well, each order number and SKU are unique. So we could argue that this determines everything else, because using the order number and the SKU, we've got the price, we know how many they bought, and by extension we know the extended price. So these are the two functional dependencies in the order item table. And we can actually validate this one because it's the primary key. It's the primary key of the table. Using order number and SKU, we can uniquely identify everything else for every record. Now, what we would do is we would wind up doing something with this functional dependency to make it match good table design. So we will get into a little bit more with that in the next lesson, and then we'll be done for the week.